topic today is easy as pie, and I couldn't resist. No, we're not talking about this kind of pie. We're talking about the small single board computer. And here's a few examples. And when I started digging into Pi, I rapidly discovered that the amount of material on the Raspberry Pi is absolutely overwhelming. So this is actually, I stole the promotional poster from the movie The Perfect Storm, because dealing with Pi publications and Pi announcements. There we go. How'd that happen?
What happened?
Okay. Am I unmuted?
Yes, you're good.
Good, thank you. It's kind of like facing a tsunami. Okay. And people don't realize, but the Raspberry Pi just turned 9. In fact, it turned 9 in February. And it's rather a remarkable journey over 9 years. The success outstripped what anyone thought a small computer company could achieve. So let's start. This sort of gives you a clue. Raspberry Pi is a series of small board computers developed in the United Kingdom by the Raspberry Pi Foundation in association with the chip maker Broadcom. So they use Broadcom primarily to manufacture chips for them. And they mostly use chips that were originally targeted at cell phones, to give you an idea where they're getting their silicon from. Originally leaned toward promotion of basic teaching of computer science in schools and in developing countries. And they achieved a lot of popularity. What I thought was very, very funny was their initial goal was 1,000 units. They thought, you know, if we could put this together and sell 1,000 units, that would be great. And instead, over the last 9 years, they've sold 38 million units with 21 models.
Wow.
Yeah, it really exploded. It's the only word for it. The original perspective was a small, hackable, inexpensive computer that could be used by students of computer science. Now, by hackable, I don't mean criminal activity. I mean ad hoc design, engineering, experimentation, the sort of things that are typical in labs and in educational environments and hobbyists. And I thought this quote was very succinct. We made a toy for children, and people took it to all sorts of exciting places. That was by one of the founders of the Raspberry Pi Foundation and the CEO of the Raspberry Pi Trading Limited. Now, this brings us to an important point. Raspberry Pi Trading Limited is a for-profit company. The Raspberry Pi design is not open source. It's proprietary. And while it is very open in terms of support and other things, the actual internals of the chips they use are considered trade secrets. And that makes perfect sense because the chips they're using are from Broadcom. Broadcom does not want to give away their cell phone chip business, okay, to allow China to reverse engineer their cell phones. So it's proprietary. A contrast would be another board like the Beagle board. The Beagle board is in fact an open source product, but we'll get to that later. So, and you'll have to excuse me for the crudity of the diagram. I didn't have time to make it to scale or be absolutely complete. But where does the Raspberry Pi fit in the world of computing? So on the low end here, we have controllers like the Arduino and the Pico. And then we have the Raspberry Pi and its friends. And we have your typical laptop computer. We have desktop and gaming machines. And over here, down here, we have industrial controllers and automotive. And if the graph went about 5 yards to my right, that would be where aeronautical, aerospace, and medical controllers would be, in terms of being like 1,000 times more expensive. Anything goes into an airplane, multiply the cost by 100. The thing you should realize is all of these little bubbles have overlaps. And I've kind of highlighted it with the color. And this reflects the fact that the old lines between what's a controller, what is a computer, what is a personal computer, are blurring. Okay, so for example, it used to be that if you wanted Wi-Fi, internet access, web surfing, or communication of data through the internet, you needed like a laptop. Okay. Now someone unmuted. Okay, it went away. So but today you can get controllers that go on the, you can get controllers down here in the low end that will in fact go on the internet. So while this is still true, the lines are blurring. In case anyone has any doubt, the Raspberry Pi has many friends. And these are a very, very brief list of some of the ones I was able to find. In fact, in the last 2 minutes, I just realized I forgot a couple already. Like the Beagle board is missing from my list, but there are others. And the trade-off is usually, I've seen reviews on all of them. The trade-off usually goes something like this. New board comes out. It's often more powerful and has better features than the Raspberry Pi, often at a very competitive price. But very often you'll find that the quality of software support is just not there. Now, if you're sophisticated enough to go on your own and don't need a lot of community support, then this may be a good idea for you. But if you're like me and you kind of like to be able to Google things and find groups that have worked on the problems before and find an active support community, that and coupled with the fact that the software for the Raspberry Pi is superior, makes it a very attractive choice, even if it's not always the most powerful choice or the cheapest choice. So let's take a quick look at the Raspberry Pi tree. Now, I'm leaving out some of the variations, and some of the ones I will mention, I'll only mention them now because I'm going to exclude them later. So there's the original Raspberry Pi, which came out 9 years ago, and it has models A and B. It came with 256 meg of RAM. The B version had network access. None of them had wireless, and I will deal with these other things later. And it was a standard size. It was supplanted by the Raspberry Pi 2, the Raspberry Pi 0, the 3, then 4. So each next, just for reference, I chose Amazon.ca. And I figured by using Amazon.ca, I'd have a level playing field for what was available. Now, so in each thing, we list what kind of Pi it is, how much it costs. Again, this is Canadian dollars to ship from Canada. And what other stuff do you need to make this into a working computer? Right? You get a Raspberry Pi. I should have brought mine up. It's downstairs. It's all set up. You get a Raspberry Pi, and what you get out of the box is a very inefficient paperweight. You need extra stuff to make it usable. So if you buy, let's say, a Raspberry Pi 3, what are you going to need? You're going to need a power supply, a case. Well, you can kind of get away without a case if you want to go rough and ready and just have it lying on a piece of cardboard. Don't put it on a metal disc. It will short out. You're going to need a cooling system. That's just, you can get away without one. All the Raspberry Pis will slow down when they overheat. The really, really early Raspberry Pis run so slow that they don't overheat. But a Raspberry Pi 4, for example, is such a powerful processor that you should always plan on a cooling system. You're going to need an SD card with an operating system. And people will remember my talk in, was it April, where I talked about SD cards. You're going to need an HDMI cable to plug to your monitor. You're going to need a keyboard, a mouse. Oh, and by the way, the monitor to accept the cable. Okay. The Pi 3 can also be purchased as a starter kit. So what does the starter kit get you? Well, it gets you a lot of those other things. And all you need to do now is provide a keyboard, a mouse, and a monitor. It costs a bit more money, but you're no longer hunting around for all these bits and pieces. They're already there. It comes with a case. It comes with a cooling system. It comes with an SD card pre-programmed with an operating system. It comes with a power supply. And by the way, the #1 problem with people with Raspberry Pis is using power supplies that are too wussy. You know, you may not be able to use your cell phone charger for this. I'm just saying. The Pi 4G, the Pi 4 and 8 gig. Again, you pay a bit more for 8 gig. And remember, this is all in a credit card sized computer. And they require the same as the Pi 3. Then finally, the Pi 4 starter kit cost $135. It comes with 4 gigabytes, by the way. And it also just requires a keyboard, mouse, and monitor. In fact, the Pi 400 comes with a complete kit. I guess it includes power supply and everything you need. And all you need to do is plug in a monitor. Okay, so we'll get into we'll see some more of these later. It has a free operating system, Linux. What's the magic word to get what you want? Sudo. Anyone who knows Linux will get that joke. Anyone who uses the Raspberry Pi will get that joke. That was sent to me by a friend and I just had to use it. It was just too funny. Okay, form factor. Another very attractive feature of the Raspberry Pi versus your typical mini AT motherboard or a laptop or what have you, is it's very small. This is attractive to people who want to build the Raspberry Pi into something else. You know, they want to make a device that uses the Raspberry Pi, and so they want to integrate it into a case of their own design. So the standard size is 85.6 millimeters by 56, basically credit card size. There is a slightly smaller one that's squarish, but that's kind of a rarity. The Pi Zero is even smaller. It's like a stick of gum. Well, a big stick of gum, but 65 millimeters by 30 millimeters. It's even tinier and even better at being integrated. And we'll deal with the Pi 400 special. The Pi 400 is special. We'll deal with it later. Another area where the Raspberry Pi shines is power consumption. Now, it's using a cell phone chip, basically. Okay, without cell phone, without the radio, because the radio is almost always a separate chip. But this is the brains of what would be a smartphone. And smartphones run on batteries, and they need to be very, very economical on how much juice they burn. So, whereas here's some typical examples. I did my best to get some comparative data. A Pi 3 will consume between 1.5 watts at idle to up to 7 watts when maxed out. I'll be honest, I've never been able to get it that high. The Pi 4 is very similar, but its resting power is higher. So it rests at 3 watts and goes to about the same 7-ish watt figure. My desktop PC consumes 86 watts. 45 watts is the screen. Now, I don't know what the maximum power consumption is, but I was drawing 182 watts when playing Fallout 4 and taking out the gunners in Quincy. Okay. It was a really complicated scene with lots of stuff happening. Me and the problem solver were busy at work. Okay. My Toshiba laptop, which is back here, but this okay, doesn't matter, consumes 26 watts. I didn't have anything to stress it out. And I have a really, really crummy old to-go laptop with an Intel Atom in it, which consumes 16 watts. Again, I don't have any maximums on these, but you can see how even compared with frugal laptops, the Raspberry Pis are very, very low power. And we'll touch upon how this is useful. One of the things that people use Raspberry Pis for is in services or things where they need to be on all the time. I've seen people put Raspberry Pis on mountaintops powered by solar and batteries. Clearly, the more power it burns, the bigger and more expensive a solar array you're going to need. So this is power consumption. Finally, we talk about specialized I/O options. Okay, now, the picture here is of a Raspberry Pi 4. Other Raspberry Pis will vary slightly in details, but the stuff I'm going to point out, they all share. Well, except for the Raspberry Pi Zero, which is smaller. And the 4 areas where the Raspberry Pi has unique and specialized I/O is it has something called GPIO ports. It has a display port, which is designed to connect with a flat panel, a flat flex cable to an LCD. It has a camera port, which is designed to connect with a flat flex cable to a camera module, and has an audio video port. Now, the first 3 are virtually identical in all the Raspberry Pi models. The audio video port changes from model to model. You'll have to look it up. You'll notice I haven't mentioned what I would call conventional I/O. I mean, virtually every laptop or desktop is going to have an Ethernet port. They're all going to have USB ports. They're all going to have HDMI ports. So I'm not including those as special. Okay, we're just focusing on what makes the Raspberry Pi unique. So GPI here, you may remember old PCs. People used to do weird and funky things with the parallel port. All kinds of gadgets would plug into the parallel port. For the really adventurous, they'd make their own plug board that would plug into the ISA slots on the XT and the AT machines. But that was only for the most adventurous. But really, lately, if you look at any modern laptop or tablet, there's nothing that comes close to GPIO. And what's the attraction of it? Well, GPIO allows easy experimentation and easy communication with simple devices. For example, I don't know if this is going to come out, but oh boy, I'm done in by my own background. This is an example of a device I bought at a company called Sayal, which is in Toronto, Scarborough. And this is a digital temperature and humidity sensor. This is the sort of thing you might be able to connect up to the GPIOs. The GPIO header on the Raspberry Pi is so popular that it's become a de facto standard. So that all the Pis support the same header, as well as all the Pi friends support the same header.
What does SBC stand for, Peter?
GPIO stands for General Purpose Input Output.
And what does SBC stand for?
Sorry? Oh, sorry. Single board computers. My bad.
Thank you.
I have the volume turned down just in case it was me that was echoing. Okay. And the cool thing about GPIO is that it's taken off as an industry standard. There are tons of boards available now that plug into it. And the beauty of GPIO versus, I couldn't even imagine the engineering required to build something that would plug into a PCI slot in a modern computer. I mean, you would need FPGAs, you would need all kinds of fancy, really complicated designs, and it would be a very expensive effort. Building something that goes into GPIO is something you could do with a prototype board for virtually no cost. So the number one thing people do when they get a board or a controller is the first project, kind of like the Hello World. Kerningham and Ritchie, when they published their book on the C programming language, started everyone off by having them all enter and run a program that just printed out Hello World. And it was a really useful thing for C programmers because it basically told you your C compiler is working, your linker is working, you're creating executable code, and you're running executable code to get it to print Hello World. It basically verified that, for the most part, your compiler chain was not fracked. In the embedded world, the Hello World program is called Blink an LED. If you can get an LED to blink, that means you've been able to successfully write a program for your embedded system, put it in the embedded system, and get it running. And we'll talk about more about that in a moment. Why turning an LED on and off is not as trivial and silly as it sounds. The GPIO supports boards called, and I don't know where this came from, hats. So you have a Pi, you can have hats on your Pi, and they stack on the Pi and they allow you to do things. And here's some examples. You can control motors, lighting, heating, display data. So no, you can get display hats, by the way, so that you don't need to plug in a big monitor. You just need to display a few pieces of information. You don't need a big screen. You can sense light, temperature, humidity, position, motion, user input, and more. So here's my Pi blinking an LED. Now, the same signal that blinks the LED here could be a relay. A relay actually contains an LED in it. You can't see it because it's sealed. It's sealed for good reasons, by the way. On the other side of the board is a light activated switch. Basically, it's a switch. No light, switch is off. If the LED lights, the switch turns on. Very simple. But we're not talking about a switch for to turn on a small LED. Typically, these solid-state relays can control loads of many amps at very high voltages. You could literally turn on and off lights, and heck, if you wanted to have it turn, do that. At this point, I have to put in a disclaimer. Forget pinch of salt. You all got to go out and buy a 5-pound bag of salt, because this relay controls voltages that may be highly deleterious to your health and continued life. Do not attempt to use this unless you are skilled as an electrician. I don't mean electronic hobbyist. I mean electrician. If you don't know how to wire up a fuse box or run a line for a dryer, stay away. Okay. But in fact, this came out of a unit. This unit isn't in use now because this unit was underrated. This unit is wimpy. It's only a 10 amp unit, and it was controlling a load that was supposed to be under 10 amps, but we were unhappy about how hot it was getting. We felt that we were running it too close to the limit, so it got yanked, and a 25 amp unit got put in its place, so that there would be no issue of. And not only is it 25 amp, it's also rated for double the voltage. Okay, so it's a 450 volt unit at 25 amps. So there's no more problem with that. So that's sort of a backstory. Hats. Let's look at some hats. First one we have here is called a relay hat. Basically speaking, it allows the Pi to control relays, and relays are mechanical switches that are activated magnetically. So that's 4 magnetically activated switches. Excuse me. The next one, believe it or not, that's very colorful over here, is called a sensor board. What it contains is a humidity sensor, temperature sensor, barometric pressure sensor. It even has a little tiny little joystick over here. And it has an 8x8 array of color LEDs. If you want to display something colorful. Okay. The one in the bottom left is what's called a motor controller hat. This is used a lot in robotics. These are stepper motors. These are motors that can literally be commanded to move forward so many steps, each step being a precise angle of rotation. So for example, if you want to have precise control over a robot arm or the motors of a robot moving forward, you can use stepper motors and literally tell it exactly how far forward to move. Final example is a simple Pi hat with a color display. And on the bottom, I don't know if you can see them or not, but they're, I gotta be careful. There's little switches for user input. So for example, if you wanted to build an embedded application, a small one, okay, that would be perfect. You wouldn't need to have a big old monitor or anything, and you could use the 4 buttons to navigate through your menu. Okay, so having said all these things, and having known that I mean, even my Raspberry Pi sat on a shelf way too long. What is the target user? Well, the initial market was students of computer science and engineering. It has been embraced by student hobbyist engineers, systems integrators, custom engineering companies who like to embed the Pi into things. One area where the Raspberry Pi is very popular is in controlling, well, people used to be in controlling 3D printers. Even though now they tend to be more specialized boards. But it's the same basic kind of computer. And the final category is what I call makers. The maker movement started about 10-ish years ago. It's hard to say. Around the same time as the Raspberry Pi, actually. And they initially adopted the Arduino, but they've also adopted the Raspberry Pi. And most of us are consumers. When we want to buy a new computer, we go online and we order a computer, or we go to the Apple store and the geniuses tell us what we need. Makers aren't like that. They don't consume, they make stuff. That's what their whole philosophy is. And they put stuff together and they build. And they have really embraced the Raspberry Pi. So for these groups, the features of the Raspberry Pi are very attractive. Finally, the Raspberry Pi 400. It's unique. As you can see, whereas all the other Raspberry Pis look like little circuit boards, the Raspberry Pi 400 is actually built into the keyboard. Okay, and this is the Raspberry Pi starter kit. It comes with the Raspberry Pi 400, a power supply, a mouse, even though any USB mouse would work. They have their own cutesy looking one, a video cable, and an SD card pre-programmed with the Raspberry Pi OS. The only thing you need to make this work is a monitor. This is probably the lowest barrier to entry of any Raspberry Pi. It has built-in Wi-Fi, it has built-in Bluetooth, it has built-in all kind of other things. So even if you don't have an Ethernet cable or a wired Ethernet, you can still get it to run on the Wi-Fi. Okay. So one task, and I actually did this. So one task every Pi user is going to need to do is to get an operating system. And there's two routes you can take. You can either start with a pre-programmed card, and the bundles and the starter kits include pre-programmed cards, but I didn't have one of those. I just had a bare naked Raspberry Pi Model B, the slow, dumb one, the old one. And I had decided that for this talk, its days as a paperweight were over. So you can already use something. You can also use something called Raspberry Pi Imager, available for Windows, Mac, and Linux. It will step you through what you need to do. Now, if you don't want to use Raspberry Pi Imager, you know, if you want to enter into the Iron Man equivalent of Raspberry Pi configuration, you could do it manually. I don't see the point in all the suffering. So here's what you'll need to use Raspberry Pi Imager. Here's what I needed anyway. You'll need to visit raspberrypi.org/software, and don't worry about writing down links. We'll talk about links later, and we'll show you where to find the stuff you need. But here's what I started with. I had a device that allowed my desktop machine to talk to an SD card. Okay, which is this snaky thing here, and of course an SD card. And download and install the Imager program, run the program, plug in the SD card. Okay, this is an actual picture of my running So first you must choose an operating system, and then you must select the appropriate device. Now, I cannot stress enough, please do not inadvertently choose your main system hard drive. Bad things will happen. Actually, it won't let you. But on my system, I had my backup drive and my SD card both visible, because my backup drive is USB attached. And the RAS, as opposed to, if I had chosen the wrong drive, I could have wiped out all my backups. Bad news. So you basically select the SD card storage device and you tell it to write. And I was very gratified to see, not only does it write everything, but it verifies everything. And make sure that it wrote correctly. It took on my machine, it took about 15 minutes, but your mileage may vary. Okay. One little clue, especially if you're doing this under Windows, when it's done, it will tell you to don't touch anything, don't look at anything, remove it. The Windows immune system will detect a foreign file system, and it will already be launching antibodies to attack and destroy it and reformat it into a Windows recognizable partition. It was already had in the background Windows open saying, "Can I reformat this, please? I don't recognize it." Take it out. The only thing protecting your drive, as far as I can tell, is the fact that the Imager has it open to exclusive use. Or Windows may already be trying to root around in it. So just a little footnote. Pull it out, then.
What does YMMV mean?
Oh, your mileage may vary.
Oh, okay.
Sorry. So, there we go. What was that all about? Okay. So this is my actual Raspberry Pi with actual dirt on my old desk. So all the connections you can see I have back here, it's kind of upside down because it faces on the back of the card. But there is my old, there's my SD card. It's been plugged into an adapter because this old Raspberry Pi has a full-sized SD card adapter. You can, there over here where the mouse is, you can see that's the power connection. It goes over to a cube that I normally use to power my, to recharge my Android tablet. For an old Raspberry Pi like this, you can get away with a lot because they really do not hog a lot of power. Down here on the bottom, that's my video cable going off to my screen. Next is my Ethernet cable. This really old Raspberry Pi does not have Wi-Fi, so wired only. And it's a little hard to see, but there's two USB connections. One of them, and that's only took me 3 tries to get it right. But there you go. I was a little nervous, but that's our basic Raspberry Pi. Now, this is a very old Pi. So it's, for example, it only has one HDMI connection. The Raspberry Pi 400 has 2. It has an older audio video output over here. So, but the ideas are the same. And when you turn it on, this is what you're welcomed with. Raspberry Pi OS. And after a lot of setup screens, a lot of patience, and a lot of, you know, I just downloaded the Raspberry Pi OS that day, and installed it that day. And of course, the first thing I had to do is about 45 minutes worth of software updates. My Raspberry Pi is a slow one, I won't lie. But eventually you get to this screen, and you hit restart, and to quote Dr. Frankenstein, Igor, the monster lives. And this is what you're presented with. There's an actual photo of my Raspberry Pi up and running with the only keyboard I could find loose, which is my ancient Logitech. You can see the mouse down there. You can see it all. That is an actual shot, an actual photograph of my Raspberry Pi booted up. So now what? Right? I mean, what you have here, in my case especially, is a very slow old Linux machine. So to be useful, it needs an application. So let's take a look. But first, people have asked, can a Raspberry Pi be used as a main PC? This question has come up and people have done videos about it, where they use a Raspberry Pi as their only desktop for a whole week. They were usually doing it with Raspberry Pi 3s or 4s, not a Raspberry Pi A or B. And the later models are better at doing this. And why the dog standing on 2 legs? Well, when a dog stands on 2 legs, people don't criticize the dog for not doing it well. They're amazed that it can do it at all. And using an old Raspberry Pi as a desktop falls under the "it's amazing they can do it at all" category. But desktop piece replacement is not what a Raspberry Pi is all about. So let's look at another application. This is a real one. A cousin of mine built this, actually. It's called the Raspberry Pi Cupcake. It is literally a hand-sized emulator of video game machines. One of the uses of Raspberry Pi is emulating old computers. Now, the Pi is not a fast machine by today's standards, but a Pi 3 or a Pi 4 is running at 1.5 gigahertz. And the original old arcade machines ran at 4 megahertz. There's a big gap between 4 and 1500. Raspberry Pi has more than enough horsepower to emulate any old video game. And they got an example of it doing Pac-Man. That's actually the old arcade Pac-Man. So that was a fun one. But let's move away from silliness and discuss something more serious. Pi-hole. This is what I'm going to be using my Raspberry Pi for when I'll explain more later. And the Raspberry Pi, this is an awesome example of the Raspberry Pi as an appliance. In this case, a network appliance. Now, what the Raspberry Pi Pi-hole does is it acts as a net blocker, an ad blocker to all the devices on your LAN, on your local network. And that means it's able to act as an ad blocker for things that can't run ad blockers, like tablets, like your phone. At least my phone doesn't have an ad blocker, or other things. Also, it ad blocks even for websites that complain about ad blockers, because it's not running on your machine, it's running on another machine in the network. But to do this, to be a network appliance, it needs to be on 24/7, as an example. And this is where the small size and the low power of the Raspberry Pi make it perfect. I mean, if I had a big desktop machine doing it, and you can, it would be burning 100 watts of power day and night all the time. And you would really see that in your electric bill. It would add up. The Raspberry Pi consumes about 1 watt idling. Okay, so let's take a look further. How does it work? The Pi-hole sits on your network acting as your personal domain name server, DNS. And at this point, I'm going to have to use a Star Trek analogy. In Star Trek II, when Khan had attacked the Enterprise and the ship was wrecked, they come up with the plan to hack their way into their enemy's ship using the prefix code. And Saavik asks Captain Admiral Kirk, "What are you doing?" And he says, "Saavik, how do things work in a starship?" Well, DNS is the answer to the question, how do things work in the internet? It is the underpinning that almost no one knows about. The DNS takes a web name like www.google.com and translates it into the Internet Protocol address, which we know is a bunch of numbers with dots. The Pi-hole works by acting as your domain name server on your network, doing this translation work. It has a list of all known advertising domains. And when it sees one, rather than translating it to the Internet Protocol address of the advertiser, it translates it to a blank address that returns no data. It's the World Wide Web equivalent of connecting it to /dev/null for us Linux heads. So the website thinks it's serving up ads, but it isn't. The website thinks it's connecting to www.testosteronead.com. And it does connect to something. It just doesn't return any data. No pop-up appears, nothing appears. And again, this works for software that cannot run an ad blocker. Now, I could have done a really deep dive on the Pi-hole, but someone else is already doing that. The CP user group of Pittsburgh is planning a Pi-hole live install and setup for June 19th. And I got an email from Hugh Crawford about getting details for attending that event. If you're interested in using a Raspberry Pi to protect your network from unwanted adware, then I would contact Hugh and try to get on this list of to get into this this live presentation. I know I'm going to do it. I'm very interested to see what they come up with, and hopefully, CP User Group of Pittsburgh will record it so that people who missed the presentation can see the recording. And who knows, maybe we'll do a our own build your own Pi-hole event. I don't know. I mean,
Hey, Peter,
yes,
this is John Mazer from the CP user group. We are planning on recording the pie hole build. So if any of your members miss the event, they'll be able to get a recording of it. So just wanted to let you know.
oh, that's fantastic. That's fantastic. Because I know people may be interested. Awesome. So, Alexa, stop. Sorry. My personal digital assistant kept interrupting me. Where was I? So yeah, so they're doing this awesome presentation, and I'm looking forward to it. And now my phone. Okay, hang on. There. Sorry. Okay. Okay, so we're near the end of the talk, which is good. We've about used our time. And normally at this point in time, I would have a huge list of references with QR codes, but I've moved on a bit. I just list two. First is Wikipedia. If you want to find out anything and get in depth, Wikipedia is your #1 go-to place. But I have created a GitHub repo of talks. Currently, it only has my 3 talks: the GitHub talk, the SD card talk, and this talk. So if this works, let's see if this works. Aha! Igor, it lives. This is taking me to the GitHub repo I created on GitHub, and there it is. There's the Raspberry Pi talk. And rather than having dozens and dozens and dozens of links in the presentation, they're all here. So again, I'll link to Wikipedia. I'm a big enthusiast. A link to the Raspberry Pi website and to Imager. A link to some suppliers. These companies are good for dealing with Canada. There's a lot of suppliers in the States that will not deal with Canada. It's very annoying. It pisses me off. I don't know if I should say it. It doesn't sound presidential to say that. It annoys me greatly. But these are ones which are reliable and do well. I haven't listed AliExpress or eBay or a bunch of other things. You could look there too. And you might get a better price, or you might be shipped dead stuff. Just saying. Sayall is actually a brick and mortar outlet in Scarborough. And that's where I go for it when I want to actually see the stuff before I buy it. And we all know what Amazon.ca, they sell everything. I put some links for Pi-hole. I put some links on from Tom's hardware page. They've done some excellent stuff with the Raspberry Pi, including its 9th birthday, Pi projects, accessories, and even an in-depth look, a deep dive, sorry, on the GPIO and what the pinouts mean. Like I said, the Raspberry Pi GPIO header, that 40-pin header, has become a standard for interfacing. So a lot of other companies have started using it. And then the next section is kind of self-explanatory. So many Pi articles and videos. Do not amuse yourself to think that this is a complete list. This is maybe 1% of what's out there. Okay, it is a massive amount of material. I mean, some of these articles should give you a hint at how creative people are getting with the Raspberry Pi. Like the first one, Cosmic Pi, detecting cosmic rays with a Raspberry Pi. Yeah, there's some gossip, like, is a Raspberry Pi coming in, Raspberry Pi 5 coming in 2021? Maybe. And then people who want to use their Raspberry Pi for greater secure applications, like setting up 2-factor authentication. Okay. Does everyone, most of us should remember the gasoline pipeline company that got taken over by, what do they call it? Well, crimeware. And they had to pay a $5 million ransom to get their network back. And they traced it down to an access port where they hadn't bothered to set up two-factor authentication. That was the entry of the criminals. Just one little weak point. Just thought I would mention that. They're using it in ham radio, new features. This is a cool one, VoidStar Data Blaster, a wearable cyber deck. Apparently some people are into their science fiction. He used a Raspberry Pi to build an ARM-mounted computer with a display and a heads-up, an optical display, and all this cool sci-fi. That someone makes a specific single board computer to accomplish that task. So it's worthwhile to look beyond just the Raspberry Pi if you have a special need. And I don't know, have we had questions? If not,
Not yet, nothing on chat.
okay, good. So if anyone wants to, if anyone has a question, they can unmute and just ask it.
Hey, Peter, this is John Mazer again from the CPU user group.
Howdy.
I just wanted to mention that regarding our Pi-hole live install, everybody who wants to participate needs to reply back to the Google form that was embedded in the document that we sent to Hugh. So if you're planning on doing the live install with us, make sure you reply back to that Google form.
Okay.
And send it into the member who's doing the presentation for us. Also, the other thing I wanted to mention is you must have your operating system installed. This is not, us helping you get your OS installed. This is, you have to have your OS ready to go because the only install we're going to be doing is the Pi-hole install.
Got it.
So I just wanted to make that clear to everybody that, hey, they're having trouble getting their OS installed. That's not the point. You need to make sure that is done ahead of time and it's ready to go so that when our member is presenting, you're following along and doing what he's showing you to do live. So just
Got it. Half of the PowerPoint is actually here.
Oh, okay. That's it there. Okay. So that's the
Yep.
whole thing. Okay.
Yeah.
All right.
So basically, I put up all the appropriate materials. The PDF is there. Everything you need is up there.
Okay. All right. Good enough. And the last thing I wanted to mention, and I'm sure some of your members know this, but there is a publication called Raspberry Pi Magazine that is available for download on the web. If you just Google Raspberry Pi Magazine, it'll take you to the download page, and you can download the PDFs of every single issue, starting with number 1. So
Fantastic.
just
I'm
wanted
going to
to
start
throw
doing that.
just wanted to throw that out in case your
Awesome.
members did not know that. So that's all I have to say. Thanks. It was a great presentation. I appreciate it.
Thank you so much. Okay.
Peter,
Yes.
one question. How about the orange pie? Because you forgot to mention also orange pie.
Actually, believe it or not, the orange pie was on the list of pie friends. Clearly, I didn't have. If I tried to even touch upon the major Raspberry Pi similar machines, this would be a semester course at a college, not a presentation. But no, it is the Orange Pi is a device that lives in the same space as the Raspberry Pi. It suffers from the same problem that a lot of Pi competitors have, and that its software support isn't quite to the same level as the Raspberry Pi is. The Raspberry Pi Foundation has done a phenomenal job getting all the bits and pieces to work. So when I saw the review of the Orange Pi, it said basically a great board, but this and this didn't work. And if you could live without those, then it's perfect. Otherwise, you might be in trouble.
Peter, how did you get to that
Okay.
page that you're looking at?
Okay, so hang on. Good question. So this is off of my GitHub repo, and what I'm going to do,
Can you put that into the chat maybe?
yeah, but I'm trying to figure out where is the chat. There is the chat. I'm going to put a link to that into the chat,
That would be good.
and that is a link to the PyTalk,
Perfect. Thank you.
and it links you to the PDF. It links you to the page with all of the links, and you can even look at the summary if you want to see the summary again.
Yeah, that's
So now all of these are active or all live links. So for example, if I click on, I don't know, pick one at random. I click there, it takes me to that YouTube video,
This video has been supported by JLCPCB.
along with all the advertising they put on it. But these are all live links. Okay, and like I said, if you go into YouTube and just search Raspberry Pi, you'll be inundated with videos. Assuming you filter out the ones for recipes for Raspberry Pi. Anyway, I think I could, all right. I guess it's stop share. Okay.